I am Bhaskar, Assistant Professor, Department of Mathematics, Sai Vidya Institute of Technology. In today's class, we are going to see the jet transforms. Why we will use these jet transforms means to simplify the difference equations. What are the difference equations is studied already. So to simplify the difference equations, we will use these jet transforms. Right, where you have been studied this difference equations means in the numerical methods you have been studied it in forward, backward, divided difference like that we have studied it. There you have been studied it these difference equations. To simplify the difference equations, we will use these jet transforms. Right, we'll see first. So jet transforms. Jet transforms. What is the definition of jet transforms? We'll see. Definition of jet transform is, right, if un equal to u suffix n equal to un equal to f of n defined for all n equal to 0, 1, 2, 3 and so on, and un equal to 0 for n less than 0, then the jet transform of un, then the jet transform of un, then the jet transform of un denoted by jet transform of un equal to summation of n equal to 0 to infinity u suffix n into z power minus n. This one I'll take it as equation 1. Whenever this containing the series, this series converges when RHS of equation 1 converges, when RHS of equation 1 converges, it will be a function of z, and we write this z transform of un equal to, will converges means we'll write this z transform of un equal to this one only. See, summation of n equal to 0 to infinity, it will converges now. When it will converges, it will come into a function of one variable, that only I'll write u bar of z, and I'll write it as u bar of z. So here we are going to study inverse transform also. This one I will take it as equation 2. This equation 2 further can be written as z inverse of u bar of z equal to un, I will write. This is, we'll call it as inverse jet transform. This is jet transform, and this one we are calling as inverse jet transform. Now we'll take the property. Right. This is jet transform of un, and this is inverse jet transform of u bar of z. If you take for un summation term, if you take the transform, it will convert into u bar of z. If you take inverse transform of u bar of z, you will get un. Right. So this is the basic definitions of our jet transform and inverse jet transform. This equation 3 I'll take. Equation 3 is for that inverse jet transform. Equation 3, inverse jet transform. This is. Right. So now next I'll take property. So very important, this property. So we'll simplify this property. Using these properties, we'll see the formulas. What is the property? I'll write here. See, property is nothing but jet transform of property, Z transform of n power k equal to minus Z into d by dz of Z transform of n power k minus 1, n power k minus 1, where k is where k is a positive integer, where k is a positive integer. Right. So now we'll take this one and we'll simplify. Right. Proof. Now we'll take that RHS. So RHS is what? We know that minus Z into d by dz of Z transform of n power k minus 1 equal to, this one I'll write here, say minus Z into d by dz of, what is the Z transform of n power k minus 1? We know that. What is the Z transform of un? Z transform of un is nothing but, I will write summation of n equal to 0 to infinity. In the place of un, here what is there? In the place of un, n power k minus 1 is there. N power k minus 1, n power k minus 1 into z power minus n. Z power minus n. Now, I want to differentiate. See, if you see here, you have to differentiate this n power k minus 1 into z power minus n. With respect to z, I have to differentiate. How do you differentiate with respect to z? Now, I'll write in the next sheet. We'll differentiate this. What is the left hand side? We know that. So that right hand side we are taking and we are proving here left hand side. Now, you see minus, left hand side should be, so right hand side should be minus d by dz of that z transform of n power k minus 1 equal to, now I'll write here, see minus z into that, once again I'm repeating the step, minus z into d by dz of summation of n equal to 0 to infinity n power k minus 1 into z power minus n. Now you will write, so that equal to minus z into, here what is that say? I'll keep the summation here, n equal to 0 to infinity, I'll write n power k minus 1 into d by dz of z power minus n, I'll write. Now I'll write minus z into summation of n equal to 0 to infinity n power k minus 1 into differentiation of z power minus n is minus n into z power minus n minus 1. Minus n minus 1. Now you will write, see, I can multiply this and I will simplify. See here, n equal to 0 to infinity. Here minus is there, here one minus is there, here one minus is there. So it will become as plus. Now I'll write n power k minus 1 into n into z power 1 into z power minus n minus 1. Now if I'll simplify this, I'll get summation of n equal to 0 to infinity n power k minus 1 plus 1 should be n power k into z power minus n. Now if you'll see that basic definition, this only I'll write, see, basic definition according to this, see your previous definition of z transform. What does that say? Here it is in the form of un into z power minus n. In the place of un, see, in the place of un, here n power k is there. In the place of un, n power k is there. So just look there, in the place of un, n power k is there into z power minus n. Now you will write summation of n equal to 0 to infinity n power k into z power minus n, I'll write z transform of n power k, I'll write. Now at the end finally I'll write minus z into d by dz of z transform of n power k minus 1 equal to z transform of n power k, which is the required solution for the given equation. Right, next we have to prove what is the value of Z transform of right. Now this is a basic property. Using this basic property, I'll simplify the problems. Z transform of n, Z transform of n square, Z transform of n cube. That all we will simplify. So if we simplify, what we will get, we can see. Right. So next one should be. So this is the formula. I'll rewrite this one like this also. Z transform of n power k equal to minus z into d by dz of Z transform of n power k minus 1. This is the required solution for the given equation. Right. Now, next heading should be Z transform of some standard functions. Z transform of some standard functions. Right. Right. Now we can take, so first one should be in this Z transform of k power n. Z transform of k power n. So this is also very important to prove n square, that all. First one I am proving. So how do you write Z transform of k power n means? For this proof or formula, see, Z transform of un equal to summation of n equal to 0 to infinity un into z power minus n. This is a basic formula. Now I'll write Z transform of k power n equal to summation of n equal to 0 to infinity un is nothing but k power n into z power minus n. Now this only I will write, so that equal to summation of n equal to 0 to infinity. Now I'll write k power n divided by z power n. I'll write. Now this only I'll write summation of n equal to 0 to infinity k by z whole power n. I'll write k by z whole power n. Now if you'll expand this, now I'll get in the form of, Z transform of k power n equal to Z transform of k power n equal to Z transform of k power right. Z transform of k power n equal to, using that, so if you see here I use that, so that n equal to 0 to infinity k by z is there. So if I'll expand this, I'll get k power n equal to Z transform of z by k whole power 0. See, first one should be, I'll write z by k whole power. See, I've written this one should be that in the form of k by z. Here k by z means, so here I'll write k by z whole power 0 first equal to k by z whole power 0 plus k by z whole power 1 plus k by z whole square plus k by z whole cube plus and so on. Now you'll write, so this is the in the form of, if you see k by z whole power 0 is nothing but Z transform of k power n equal to 1 plus k by z plus k by z whole square plus k by z whole cube plus and so on. It is RHS, the series of RHS is in GP. It is in GP. So now we will write this one by using that formula. Z transform of k power n equal to Z transform of k power n equal to 1 divided by 1 minus k by z. If we'll simplify this, we'll get z divided by z minus k. This is a formula for Z transform of k power n. Now, in this, if I'll keep Z transform of 1. See, if you want to find, suppose if k equal to 1, if k equal to 1, then Z transform of k power n is 1 power n. That only I'll write Z transform of 1 equal to Z divided by Z minus 1. The Z transform of 1 should be Z divided by Z minus 1. Now, using this formula, we will simplify the remaining formulas. Next one, I am going to take Z transform of n. Next formula I am going to take. Second one should be Z transform of n. So Z transform of n, if you want to simplify, means we have to use solution. So this one should be Z transform of n. If I want, means I will use the formula of Z transform of n power k equal to Z transform of n power k equal to minus Z into d by dz of Z transform of n power k minus 1 minus Z into d by dz of Z transform of n power k minus 1. Now, in this formula, put n equal to 1. If you give n equal to 1, I'll get Z transform of n power 1. I'll get n power 1 should be n only minus Z into d by dz of Z transform of n k equal to 1 means 1 minus 1. Now I'll write minus Z into d by dz of Z transform of n power 0. Now I'll write Z into d by dz of Z transform of n power 0. Anything power 0 is 1. Now, already we know that what is the Z transform of 1? Z transform of 1 is Z transform of, say here left hand side should be Z transform of n equal to minus, not only now here previously what is there, minus Z into d by dz of minus Z into d by dz of Z transform of 1 is Z divided by Z minus 1. Z divided by Z minus 1. Now I'll write minus Z into differentiation of d by dz of Z by Z minus 1 is Z minus 1 whole square. B is Z minus 1 into differentiation of Z is 1 minus Z into differentiation of Z minus 1 is 1. Now we will take minus Z into Z minus 1 minus Z divided by Z minus 1 whole square. Now I'll write here, see, this is plus Z minus Z cancelled. So if you multiply this minus and minus 1, you will get Z transform of n equal to Z divided by Z minus 1 whole square, which is the required solution for the given equation. Right. Next formula I will write. Third one, Z transform of n square. Similarly, I will do Z transform of n square. I will do here. Z transform of n square equal to Z transform of n square equal to minus Z transform of n square. N I have written the formula, no, I didn't write. Find Z transform of n. Z transform of n square we have to find. So if you find Z transform of n square, so what we will get, we have to prove that one. So here equal to, at the end I will prove that one. Right. Z transform of n square. If you want this one also, we will use that basic formula for that. Z transform of n power k equal to minus Z into d by dz of minus Z into d by dz of Z transform of n power k minus 1. Now k equal to 2, if you will take Z transform of n square equal to minus Z into d by dz of Z transform of n power 2 minus 1. So that equal to minus Z into d by dz of Z transform of n. What is the Z transform of n is minus Z into d by dz of Z transform of n is Z divided by Z minus 1 whole square. Now you will write minus Z into Z minus 1 whole square. See this one, Z minus 1 whole square is there. That square I will do. If you will do that square, you will get here Z minus 1 whole square. This is V into differentiation of Z is 1 minus Z into differentiation of Z minus 1 whole square is nothing but 2 times of Z minus 1. Now, if I'll simplify this, I'll get minus Z into, here I'll take Z minus 1 outside. So if I'll take Z minus 1 outside, so remaining should be, inside should be Z minus 1 minus 2Z minus 2Z divided by Z minus 1 whole power 4. Divided by Z minus 1 whole power 4. If you cancel this Z minus 1 and this power, you will get Z minus 1 whole cube. Now you will get Z transform of n square equal to Z transform of n square equal to what are the remaining here? See, minus Z into, this one should be minus Z minus 1 minus 2 is at the time minus Z minus 1 I'll get. The numerator should be minus Z into minus Z minus 1 divided by Z minus 1 whole cube. Z minus 1 whole cube. Now, if you multiply this, Z transform of n square equal to minus of minus should be plus Z square plus Z divided by Z minus 1 whole cube. This is the solution for Z transform of n square. Z transform of n square is Z square plus Z divided by Z minus 1 whole cube. Similarly, we can prove Z transform of n cube equal to Z cube plus 4Z square plus Z divided by Z minus 1 whole power 4. Right. So then afterwards, this is similarly, you can try to prove this. You will get the same way. N square have been done. So you have to prove for n cube or all. Next, damping rule. So what is the damping rule? I will tell. So damping rule is nothing but damping rule is nothing but if Z transform of un equal to u bar of Z, then Z transform of k power n into un equal to u bar of Z by k. And second one should be, this is first one. Second one should be, this is the damping rule. And Z transform of k power minus n into un equal to, we'll write u bar of k by Z. Sorry, u bar of k z. U bar of, this is zk, this is k z, I'll write. So using this, whatever the formulas up to here we have simplified, that one I will prepare one table and I can write it that. Yes, see, here first one should be the formula and correspondingly that damping rule. Yes, see, formulas I am writing. Then on that side I am writing as using the damping rule. How do you write? Z transform of 1 equal to, Z transform of 1 is nothing but what? Z transform of 1 is Z by Z minus 1. This are all you should have to by heart. Next, second one should be Z transform of n equal to Z by Z minus 1 whole square. Z transform of third one should be Z transform of n square equal to Z square plus Z divided by Z minus 1 whole cube. Z minus 1 whole cube. Fourth one should be Z transform of n cube equal to Z cube plus 4Z square plus Z divided by Z minus 1 whole power 4. Z minus 1 whole power 4. Similarly, if you use the damping rule, for this one, see, this is not, we are not using the damping rule. Similarly, if you use these formulas, first I'll write, this is fifth one I'll take, Z transform of K power N. Already I told that Z transform of K power N formula I proved, Z by Z minus K. Now using this damping rules, Z transform of K power N into N. K power N into N. Z transform of K power N into N. How do you write K power N into N means? It is in the form of, see, this is K power N into N. K power N into N. N formula already we know that. What is that N formula? We know that N formula I proved. N formula is Z by Z minus 1 whole square. Here, similarly, we can replace that and we can find that Z transform of K power N into N is nothing but KZ divided by Z minus K whole square. Next one should be Z transform of K power N into N square equal to K power N into N square equal to N square formula we know that. So that using that I'll write K Z square plus K square Z divided by Z minus K whole cube. Z minus K whole cube. Next one should be Z transform of K power N into N cube. K power N into N cube is nothing but, we'll write KZ cube plus K square Z, 4K square Z square plus K cube Z divided by Z minus K whole power 4. So understood, I think so. Here this is plus 4K square Z square. These are all we applied by using damping rule. 4K square Z square. Any doubts in this? So any doubts in these formulas, you can write, you can ask. These are formulas. After the formula, just I applied the damping rule and I have been simplified this. Right.